So again, welcome to Introduction to Parallel Java Programming. What I'll do first is kind of give you an overview of what the class is about, and then we'll dive right into the first material. So there's a bunch of topics that we'll be covering in the class. All the PDF versions of the slides will appear on my website, which I'll show you in a second. And all the videos that we record will be available on my YouTube channel. For those of you, I recognize a few people who've taken my classes before. It's pretty much the same drill, which is good. So what's the motivation for what we'll cover? There's a growing need for developers of software who know how to write concurrent and parallel programs for a range of computing platforms, spanning mobile devices, laptops, desktops, cloud server environments, and so on. And you'll see as we go through the course that that's really the target of what we're covering. This is coming from a number of forces, a number of demand functions, not the least of which is it's almost impossible to buy a non-multi-core processor these days. Almost everything you can get off the shelf is multi-core, so why not program in parallel? And of course, there's also tremendous amount of advances in disk storage and network communication and hardware platforms like operating systems and virtual machines and so on. So lots of opportunities to do concurrency. In fact, one of the things that's happened over the past decade and a half or so is Moore's law has sort of changed or evolved a bit. So does anybody know what Moore's law is? What does Moore's law say? Anybody know what that is? So Moore's not just a good idea, it's the law, right? And what Moore's law said initially was every 18 to 24 months, the amount of transistors on a chip will double. And that's been going on for a long time. What's changed circa early 2000s-ish time frame was the clock speeds started to peter out. So up to that point, clock speeds were also doubling every 18 to 24 months. But the clock speeds aren't doubling anymore. In fact, they've stayed roughly around 3 gigahertz or so for 2.8 to 3.2 or so gigahertz for quite a while, about a decade. What has changed, as predicted by Moore's law, is the number of transistors per chip. So what do you think has happened as a result of the fact that the processors aren't getting any faster, but there's a lot more transistors? What's the consequence of that? Does anybody know? So people use the transistors, exactly. People use the transistors for something else. They use them for having more cores. And that, of course, is a blessing and a curse. It used to be that you didn't have to do anything to your program but wait around for a couple of months or a couple of years and everything got faster without any work on your part. Nowadays, that doesn't happen. So you have to get smarter about how you program. So that's kind of the underlying motivation that makes people need to learn how to do parallel programming. Now, it turns out that there's a bunch of different ways to approach this problem. One would be to approach it from a highly theoretical point of view or a conceptual point of view, and we'd talk at length about the concepts involved. And we will certainly talk about concepts. However, that's not, in my mind, the best way to learn. The best way to learn is actually doing it. So this course is going to involve a lot of learning to read parallel code, obviously learning to write parallel code, to some extent learning to maintain it, although we won't really focus a lot on that, but you will get a chance to see code evolve over the course of the semester, and so you'll understand that the time spent building an artifact that will be reusable will pay off. And underlying all the discussions we'll be making will be time-honored patterns, which are ways of trying to design software so you can leverage the good insights of other people over time. We'll also be talking about object-oriented techniques, functional programming techniques, and design techniques that you can use to build more effective parallel programs. And there'll be lots of hands-on development. There'll be many programming assignments, and I'll talk more in a second about how they work. Okay, so here are the frameworks we're going to cover in this class related to parallel computing. And the class is in Java, so of course we're going to be doing Java parallel computing. There's lots of other parallel computing techniques as well. There's OpenCL, there's CUDA, there's Hadoop, there's MPI, PVM, the list goes on and on and on. We're going to be focusing on what Java does. And the three things we're going to be covering will be something called fork join pools, which will be the first major focus. The first assignment you'll do will involve fork join pools, which are ways in Java of having a pool of worker threads that allow something called fork join tasks, lots and lots and lots of fork join tasks to run very efficiently on multiple cores. So that's the first thing we'll look at. And then we'll look at a couple of other frameworks that are available with later versions of Java. So fork join pools have been around since Java 7, which is almost 10 years old at this point, 8 to 10 years. We'll then be looking at something else called parallel streams and sequential streams, which is the building block you'll need to know to understand parallel streams. And parallel streams, as we'll see, has been around since 2014 with Java 8. And it allows you to be able to take composed functions that can have content or data values flow through them to be processed and transformed in some way. And then it can map those functions to multiple cores. Really, really cool. But if that wasn't enough, right, if your brain wasn't full of cool stuff by parallel streams and fork join pools, we'll then later in the class look at something called completable futures, which is another form of parallelism, although more accurately we could probably refer to this as sort of reactive programming or reactive asynchronous programming, where you can have operations that run in the background in parallel, and then as the operations finish, they have callbacks to what are called completion handlers or completion actions, or completion stages, I guess is the right term. And then something gets triggered as a result of something finishing. Anybody here ever program with JavaScript at all? Okay, so about half the class. So if you're familiar with JavaScript, you might know something about what they call promises or futures. And completable futures are kind of like that, but way cooler. And you'll see the way in which it helps to solve some of the headaches with JavaScript with their callback hell, as they like to refer to it. Underlying all of this stuff, and in fact our first focus over the next couple weeks, will be Java 8's support for object-oriented programming, which I'm going to assume you guys all know at this point, or could learn really fast if you don't. But we're going to focus on functional programming, because that's sometimes less well known. Again, if you've done a lot of programming with modern Java, you might have some familiarity with that. But chances are, if you just went straight through the Vanderbilt undergrad curriculum, you would have been not exposed to a lot of functional programming. So that's where we're going to start. But the point of all that is just to get to where we need to be with respect to parallel processing. We're going to be using Android as the platform for doing the programs. And so you'll be running with either your Android phone or your Android emulator. We'll talk more about that in a second. But it's not really a course on Android, so there's a lot of really cool stuff related to what we'll be doing that lurks in the skeletons I'll give you for our programming assignments. Some really, really cool stuff. But we won't really have a lot of time to focus on that because we're focusing on the parallel computing. But if you're curious and want to learn about it, there's really neat stuff. And in fact, it's a wonderful way of showing how you can combine state-of-the-art graphical user interface code written in Kotlin, which is a fairly new language that comes from a company called JetBrains, and combine it with the Java code we'll be writing to do the parallel computing. At some point, well, I'll get brave enough to teach this course in Kotlin. I haven't reached that point of bravery yet, but that will be cool too. And Kotlin is a very interesting language. And you can use almost all the stuff that we'll be talking about in Kotlin as well. We may also talk a little bit about some of the Android inter-process communication mechanisms, but you won't have to get too deep into that. And you won't have to know a lot about Android. You'll probably mostly have to know how to use Android Studio, which we'll talk about, and the Android Studio debugger, which is also fairly straightforward. If you're curious and want to learn more about Android, there's a massive open online course, or a MOOC, that I put together several years ago, which you can enroll in for free and follow along and watch the videos if you're so inclined. You don't necessarily need to do that to do this class, but it could be kind of interesting if you want to learn more about Android. We'll also talk a little bit about some mobile and web communication mechanisms, so the ability to do gets and sets, or gets and posts and so on, and also the ability to download content using various Java APIs. I won't spend a lot of time on that. Your skeletons that you'll have as part of the assignment will do that stuff, and I'll give it to you so you don't have to spend a lot of time on it yourself. That's also a very interesting topic area, of course. And something else that'll kind of underlie a lot of what we're going to cover will be parallel computing patterns and frameworks. That's also lurking underneath the covers for almost everything we're going to talk about here. Depending on how much time we have towards the end of the class, we might or might not spend time explicitly talking about that. Why don't you come up one more row, please? Yeah, that's perfect. But that's important, and if we have time, we'll cover it. If we don't, I'll give you references to it. Okay, so I'm going to make some assumptions here that you either already know or can very quickly learn the basics of Java. I'll teach you the functional programming stuff, but hopefully you'll know what a class is and a method and inheritance and things like that. For what little bit of Android you'll need to know, I'm assuming you can come up to speed with that. Again, you don't have to know a whole lot. We'll provide you with skeletons that should work out of the box. So you'll mostly have to learn how to install Android Studio and run the debugger, which we can talk about. I'll also mention that we have 4 TAs in the class, who I'll mention in a minute. And they've taken this class before, so they should be up to speed on all the pieces you'll need to know to be successful. And the other thing you'll need to learn about is Git. And that often flummoxes people at first, but it's really pretty simple, and the TAs will be able to help you with that as well. OK, so here's a little bit more detail of the topics. We're going to start out by talking about essentially the functional programming features of Java, which will be lambda expressions, method references, and functional interfaces. How many people here have ever programmed with any of those things? So lambda expressions in Java. OK, so about maybe a quarter of you. That's good. You'll get a lot more experience with that. And you'll see when we start talking about the functional programming parallel computing frameworks, like parallel streams and completable futures, that they use lambda expressions and these things called method references very heavily to make it easy to program these behaviors or actions. I'm going to assume that you know this part of Java. If you don't know this part of Java, that Android specialization I pointed you to has an introductory sequence of lessons, or modules as they call it, on Java programming. And so you might watch that, but you could probably pick that up. If you've taken 101, you should be in great shape here. The bulk of the class is going to focus on fork join framework, sequential and parallel streams, and completable futures. I mentioned that before. We're probably going to spend 10 of the 14 weeks on that. And a little bit of stuff, a little tiny bit of stuff on some of the communication and, depending on how much time we have, some of the patterns. We may bounce around a little bit in these topics, but I think it'll pretty much go sequentially from here down to there. You'll see that the class is organized in terms of these modules, which we just talked about. There'll be lessons that are composed of parts. Each part will be a single lecture. And I will put all this stuff on my website. So if you go here, and I will send you all this stuff in an email shortly, so don't worry about writing it down. If you go here at my website, you'll be able to find the links to the PDFs for the slides with clickable links galore, so you can always follow up with more information, and also pointers to the YouTube playlist where I'll have all the material. I've been putting my material up on YouTube for the past 5 years or so, and there's quite a bit of material there. And the other year, I decided to monetize it. And I'm proud to say, after like a year's worth of monetization, I made $100. So it's not enough to retire. I'm not going to be like the YouTubers who basically live off of their YouTube revenue. But I do think it's kind of funny that enough people watch it that I made a smatteringly tiny amount of money doing that. OK, there will be quizzes on a monthly basis. I've gone back and forth with different models. For various reasons, we're going monthly quizzes. So you can sort of think of these monthly quizzes as like, just making sure you understood what took place over the last N weeks. Most of the time, N will be 4. Next Wednesday, N will be, like 1. So they'll hold on the first Wednesday of each month, starting this next Wednesday. Next Wednesday's quiz will be very short, just making sure you're following along. Everything's closed book. We should get these things back to you very quickly. That's one of the benefits of a smaller class. You don't have to go pick your quiz up at the the quiz distribution center. I'll hand it back. It also gives me a chance to try to learn everybody's name. With class this size, shouldn't be a big problem. Since there's going to be basically 4 quizzes, it won't be hopefully too stressful, although you should definitely keep up. The best way to figure out what's going to be on the quizzes is by going back and watching the videos. Since everything will be recorded, almost everything will be recorded. We don't record a few things, but most things will be there. And so that's the best way to learn and study for the quiz. Go back, watch the videos. You can speed them up, you can slow them down, you can come to office hours, lots of opportunity to get help. I'm a big stickler for attending class. We'll talk more about that in a minute. So make sure you show up and get your quiz. Sometimes in the past, people have just they only come to class for the quiz. So to disincentivize that behavior, you get penalized if you don't show up to pick up the quiz. So if you take a look here at my website, it explains the policy for that. There'll potentially be a cumulative final. Sometimes we have it, sometimes we don't. It kind of all depends on how much time is taken for the programming assignments, which is a little variable based on how easy or hard you guys find them. Most likely, we will have a final. The final will be worth about 10% of the grade. And the final exam will be held from 2 to 5 on Monday, December 10th, here in this room. All this information is on my website, so if you forget about it, don't worry. I'll have it up there for you to find. But again, sometimes we skip the finals. The programming assignments will all be written using Java 8 via Android Studio. And you're welcome to use any IDE or any version of any IDE. However, your final submission, the one that you submit for a grade, or for review, actually for a grade, has to build and run properly with Android Studio 3.2.x, I'll talk more about that in a second, and Android Pie 9, which is API version 28. That's the one that literally just came out. I think it came out earlier this month. So it's brand new, hot off the presses. You'll be using the latest and greatest versions of all the tools. Some of you who've taken my classes before, you'll just have to upgrade your stuff, and it's not a big deal. I'll show you how to do that. We'll be using Android Studio with Java 8. You'll have to install the Java runtime environment, Java RE. I'll talk more about that in a second. We'll be using Android Studio. Android Studio has a lot of cool tools in it these days. It used to be that Eclipse was the way to do this stuff. That's long since become passé for Android development, and Android Studio is the way to go. So you'll have a lot of help. There's debuggers. There's ways of being able to build the app portion, which you won't really have to use because we'll give that to you. There's an emulator for testing your apps on your PC. I will talk about the emulator because, quite frankly, Android Studio emulator is a bit of a memory hog. So if you have a slow processor or not very much memory, you may struggle with Android Studio. If that's the case, and usually there's one or two people who have this issue, you have two choices, one of which is upgrade your laptop, which may or may not be an option. And number two, we have some computers up on the second floor of Feather and Gill Hall in room 203, I think, or 201, 203, somewhere on the second floor. I'm sure you guys know where to find that. And we can install Android Studio there, and they have plenty of memory. The downside is you have to go there to work, but at least it will help you in terms of being able to get your code to run. So, whoops, it's not Android Studio, it's Android Pie, not Nougat. Nougat was a couple years ago. So it's Android 9 Nougat, which is, Android Studio Pie. This is sort of the icon for it. And all the source code will be available. It's not quite there yet, but it'll be available there shortly on GitHub at this address, which I will also send you an email, so don't worry about writing it down. And you'll have to know enough to be able to clone the repository, which is very straightforward. If you don't know how to do that, the TAs can help you. And then just pull the code from there, do your work remotely, and then you will send me information so I know that I can get access to your repository, and then we'll use that for grading. There'll be some instructions sent in email that will ask you to add me and the TAs as basically masters of your repository. Please don't add anybody else as a master to your repository, because then they would be able to see your code, which is against the honor code. But we'll have to be masters so we can basically make comments on your code and commit them back in. You need to learn how to use GitLab. There's some instructions we'll talk about. Every once in a while, and I hope this never happens, but once in a while, there'll be a bug in the skeletons, or we'll find better ways to put some automated testing in the examples. So you may have to update your repository once in a while. Hopefully that won't be very frequent. The assignments are getting quite mature, but don't be surprised. You may have to update a bit, and that's why we're teaching you version control or getting you to use version control. It just makes life easier. The assignments are going to focus on a bunch of different ways of doing parallel programming in Java. And basically what you'll be doing, this is a really, really cool assignment. So we're going to have this user interface that allows you to download a bunch of images from a website. So websites, as you know, I'm sure, have recursive directory structure. And this particular application is a web crawler that crawls through a website starting at a certain URL and downloads all the images available on that website. So think of it like a image web crawler. And you'll see when you run this thing, it's really, really cool. And it shows visualizations of what's happening as the images are being downloaded. So you'll see there's little icons. It's a little hard to see here, but when you're when you're downloading, you can see this image is downloading. So you have an icon for downloading. This image is applying image transformers or filters to filter the images in various ways. And that's what that looks like. It's like a little funnel. Then when it's writing the transformed images to disk, you have a little disk icon, right? And it'll say, it's writing and so on. And then as the images are downloaded successfully, they show up. You get little thumbnails of all the images. So this code is super cool. It's going to make it fairly straightforward to see if your program is working, because if your program is not working, you'll get really bizarre results when you run it. But it'll also give you a chance to literally see the differences between the different mechanisms we'll use to do the computation. And so we'll start out by doing sort of a sequential program. That'll be your first assignment, just to get you up and running, learning Android Studio and some of the fundamentals of programming with Java. And that one will be really simple, and basically will run very slowly, right? Because it's all sequential. And then we'll start doing different implementations. So we use a fork join implementation, which will do one way of doing this. We'll use a parallel streams implementation, which will do it a different way. We'll use the completable futures implementation. And what you'll get as a result of this program, up here in the right-hand corner, there's a little menu bar, where you can select which version of concurrency or parallelism you want to use. And what you'll find is, depending on which one you select, you'll literally see the difference in the way it behaves. So it's a really cool way to visualize stuff. Things may change a little bit, but that's more or less what I suspect we'll do. And you'll also find, as we go through the semester, that we're going to have some really cool regression testing frameworks which can check to see if your code is doing the right thing. And so you'll have to get in the habit of running them. But if you do run them, it should tell you pretty precisely, hopefully, when things are going wrong and why they're going wrong. We won't have a lot of time to talk about how that works, but it's using a framework called Makito, which is a mocking framework that can do very powerful white box testing of your code and instrumentation of your code to check certain properties for correctness. Really, really cool. Now, the way that the programming assignments work are probably a little different from most classes, unless you've taken one of my classes before. And what we'll do initially is you'll submit the program by the due date, very important to do. So you have to submit things on time. And you can read more about that here at the FAQ that's available at my GitHub account. And then what happens is, the first thing I do is I review everybody's code. So this is one reason why it's nice to have a class of about 25 to 30 people. This gets really unwieldy with a class of 80 to 100, but you guys are just the right amount. So I will review the code. No grade is assigned at that point. I will give you, each individually give you comments, and that's why I need access to your GitHub, or your GitLab account, because I need to be able to read your code and then push the comments back to you. Then you'll get some time, typically about a week or so, depending on how complicated the program is, where you get to revise the program based on my feedback. And the other thing I'll do is, after we go through this process, I will come into class and I will go through all the frequently made mistakes that people have done when I reviewed the code. And it's pretty interesting, because people actually do some very creative, incorrect things. And so it's fun to go through them anonymously, of course. We go through the code and I explain, someone did this and maybe this is what they were thinking, but here's why it's the wrong thing to do, and kind of give you a chance to think about how to do a better job. At that point, you'll be done, and then you resubmit the program, and then it's actually graded. And we're going to hopefully use an auto grader, which you will have access to, hopefully, assuming we get all the things working in time. So in theory, if you address my comments and if your code passes the auto grader, you should do very well. So it's not, if you put in work, it's not hard to do well in this class. Sometimes people don't do work, then it's hard to get a good grade in this class. We'll talk more about that in a second. So you'll get a final grade based on what you resubmit after I give you feedback on the solution. Are there any questions about that, any of that? It's a little different model from a lot of classes, but it works pretty well. If you do not show up for class, then you will not get a grade. So huge incentive, sometimes people think, oh, I don't have to show up for class, so I'll still do well. No, you will not do well. You'll do badly. So we won't grade your assignments if you don't show up. So you got to be here. You got to participate. I'll talk more about that in a second. Hopefully it goes without saying, well, actually I need to say it because make it clear, this is not a project team-based class, so it's a project class individually. So make sure that you do your own work following the honor code. And this goes for everything: programming assignments, quizzes, final exam, and so on. It's all your own work. We aren't working in teams. Obviously, you can come and get help from me and the TAs, but your work. Every once in a while, we have problems with this. Keep in mind, I'm reviewing everybody's code. So if people start copying things, it's often very easy to tell that. And we also can run plagiarism checking software to look for things that are too close together. So don't do that. It's really demoralizing. We have to send people to the honor council. They get an F. They get kicked out of school. They get kicked out of the program. It's really bad. So don't do that. Here's sort of the criteria for the programs. The single most important thing your program must do in order to do well is it has to run correctly. So you don't have to have all the comments perfect. You can still get a passing grade if you don't have consistent commenting style or you don't do an effective job, consistent job of how you format your code. But you're going to lose big time if your code doesn't run. And there really is no good reason for the code not to run because we're going to give you all these regression tests to see what's working with your code or not. So by the time you submit your final version, you should have a pretty darn good idea if it works or not. Because if it doesn't pass the regression tests and the automated grading script, then you're in trouble. Here's a rough breakdown of the weighting of the courses. So the quizzes will be about 40%. So each quiz would roughly be 10% because there'll probably be 4 or so quizzes, which are sort of mini midterms or big quizzes. 40% programming projects, 10% final exam, 10% participation. The weightings may change, but that's typically what I've been doing. This is really important. So the 10% of your participation is sort of 2 things. First, showing up. I forget who said it, but someone said, most important things in life are just showing up, right? So show up for class. And then the other part is be involved, right? And I know that that's sometimes hard, especially for engineering students, to feel comfortable participating, but try it, take a shot, ask questions, answer questions. There'll be lots of interaction opportunities here. And I really want to stress that that's what differentiates, in my mind, a Vanderbilt student from a run-of-the-mill student. You guys are all, bright. You're maybe not extroverted, but you're capable of asking and answering questions. Be involved. It'll make it way more fun for all of us. So make sure you show up. Make sure you participate. All this stuff is described here on my website. If you just sit here and say nothing the entire class, or even worse, don't show up at all, it'll be hard to get an A, so because it's 10% of the grade. So make sure you show up and ask questions. And I'm pretty harmless as far as I try not to make fun of people if they ask questions. Are you going to ask me a question? No, just kidding. Roughly, yeah, because we'll have a quiz each month, and there's basically 4 months. So we'll have September, October, November, December-ish. I don't think I said some quizzes only have 1 question. I said the quiz that we have next Wednesday will not be as long as the one we'll have October 1st because we only will have covered a few things. It would be very rare for a quiz to have 1 question. I think quizzes usually are, maybe I said 1 page. So typically what we have is we have like 1 page. Well, for the first quiz, it'll be 1 page. For the second quiz, it'll probably be longer because it will have been 4 weeks worth of material. But it's not going to be like a 50-page, short answer. It's not going to be some enormous thing. Okay, let's get back to the technical stuff. So you'll be using Android Studio for the class. You want to go to the Java website at Oracle and download the appropriate JRE for your platform. And it should sort of auto-figure this out, but if it doesn't, you can tell it what you need. So if you're using Linux or Windows or Mac or whatever, pick the right one, 64-bit, 32-bit, and so on. Download and install Android 3.2.x. Here is the latest version. I just checked this morning. This is a beta. Don't let that scare you. It's version 3.2 beta 5, so it's sort of 3.2.5. And the reason we're doing this is because there's some new cool features that are in the 3.2 version of Android Studio that's going to make it easier for us to do the auto grading. So we want to make sure we have that stuff all in hand when we do this. So if you're using an older version, please update it. It's really easy to do. You just go to this link, and you'll see this window, and you just click on that download button, and knock on wood, it should just work. Then once you've got Android Studio involved or installed, go ahead and select the Pi version of Android, which is API 28. You don't have to install the other versions. I happen to have them installed for various reasons on my laptop, but you don't have to. Just do that, and you click Apply, and it'll update everything. Should update everything automatically. Once you do that, you'll then have to go ahead and create an Android API 28 emulator, which again, you will click create virtual device and it'll prompt you. It should be pretty straightforward if you download everything properly and you have enough memory. So that's how you'll get the emulator involved. Some of you may actually have phones that work with Android 9. I'd be a little surprised because it's really brand spanking new, but it's possible to have a phone. Most of you will probably use the emulator, so that's the way to do it. If you use the emulator and you are using an Intel chip, I recommend you enable the HackSem virtualization driver, which will make your emulator way, way faster. If you do not have this thing involved, it will be painfully slow to run the programs. So please install please enable this if you have an Intel platform, which probably most of you do. Makes it way faster. So here's sort of instructions for how to do that. If you go here, you can read that. It's pretty straightforward how to do it. You can also get access to the Android source code, either download the whole kit and caboodle or look at or browse individual classes or packages. You can also get the Java source code, either looking at individual packages or classes or just downloading the whole thing. It's not mandatory to get that, but it's not a bad idea, and it's pretty cool. And we might talk a little bit about how things work under the hood at points, and I may point you to certain parts of the code, but I'll always give you URLs so you don't have to download everything in advance. Okay, to sort of summarize things, surprise, surprise, as with almost everything in life, you get out of it what you put into it. Parts of this course will be hard work, although I particularly think it's fun because it's programming cool new things, and you'll literally be at the cutting edge of a lot of this technology. Very few people will know what you know by the time you get done, and what we're doing is very valuable because people have to take advantage of all these cores. Do not miss deadlines. The worst thing is when people start not missing the deadlines for reviews. That gets everything into a wedge because it's complicated. That's why there's big penalties associated with that. We'll have Piazza discussion groups. You can post either anonymously or with your name. We should be able to give you good answers. The TAs will review the list. Other students will review the comments. I review the comments. I mean, not review them. I answer the comments. So this is where you'll go to access the Piazza link. I think I might have already sent you invitations to this through email. If you didn't get it, it's probably because I didn't have your email address. But let me know, and I'll add you to the class roster there. A couple other things. No laptops or phones in class, unless we specifically talk about using it. Why do we have this policy? And what happens if you don't follow the policy? So the reason we have the policy is it's been my experience that, by and large, when people sit there and browse their laptops, they're usually not paying attention, or their phones are usually not paying attention, and invariably they show up in office hours and say, I didn't understand topic XYZ, and it's usually because they weren't paying attention in class. I know it's tough. I'm as addicted as anybody to my technology, but it's been my experience that it just causes problems, and it prevents people from really actively engaging. The good news is, because we're recording all the material, you don't have to worry about taking notes on your laptop, because you can always go back and rewatch the stuff. So the best way to do it is, if you have a discussion and you're like, what the heck was he talking about? Just write on a piece of paper the slide number or slide numbers where we had the discussion, then go back and watch the video, and you'll get it all. So I'm a pretty big stickler on this, just because I find that people get distracted and they don't pay attention, and then they get lost. And I don't want anybody to get lost. There's so many ways to get help. We got tons of office hours. There's pretty much every day of the week we'll have office hours. My office hours are Monday and Wednesday before class upstairs in the atrium, which you'll always find me up there probably a little bit before 8. So feel free to come. I'm also available online. I'll talk about that in a second. Online forums, the textbooks, which if you look at the website, it gives you the links to the recommended reading. You don't necessarily have to have those textbooks, but they could help. The best way to learn stuff is the slides and the links. There's lots of links with more information about the topics. And of course, the video lectures, which are kind of the secret sauce of the class. Please resist the urge to email me directly, unless it's like, I want to drop the class, or I'm struggling with depression, or I'm struggling with exuberance, or I want to drop out and start up a company. Those kind of things are fine. But please post stuff to Piazza if it's questions about technical stuff. Why? Because then everybody can help answer, and then everybody can benefit from the questions. And you can post anonymously, so you don't have to feel that anybody will mock you for asking a completely ridiculous question, because that will not happen. Another thing I want to point out, you guys have probably figured this out by now, but I just want to underscore it. Why do we why do we put up with working so hard in these topics? It's because there are amazing opportunities that come as a result of this. I looked last night on the top paid majors for the class of 2018, right? So people who graduated last spring, who were the big winners in the starting salary sweepstakes? And surprise, surprise, it's engineering students and computer scientists. At Vanderbilt, I think for the past 2 or 3 years, the starting salary for the computer science graduates has been roughly $100,000 a year as a starting salary, which is pretty amazing. And I think that's been the top of the engineering school for a while. It used to be that the chemical engineers were doing better, but I think we've overtaken them. Of course, with that comes a few caveats that are worth knowing, right? The people who are making the big bucks are probably going to Silicon Valley, where they're paying $5,000 a month in rent to live in a 400-foot apartment with 6 of their best friends. So there's pros and cons. But the good news is, there's a huge demand for the kind of stuff that you're learning here. And you guys are at a really great time at Vanderbilt to be doing this stuff, because we're really focusing on these topics in a way that we've never done before. So it's exciting. And then finally, I'm obliged to tell you, if there's an emergency, there's a plan to get out of this building. And it involves screaming and running around up the stairs and out the building. So that's what we do if there's anything that goes wrong. I hope we do not have any problems, but if we do, that's the evacuation plan, is to go up the staircase. Don't take the elevator, for example. I guess if there's a fire on the staircase, we will have to reevaluate our exit plan, but that is very unlikely to happen. I should also mention that this is one of my favorite places to teach classes at Vanderbilt. This classroom is fantastic. We've got more monitors than you can possibly imagine, so you can keep track of what's going on. And it's also sort of aesthetic and sort of soothing to watch. Okay, so that is the